So let us begin with the first lecture on this channel, and it is on dimension analysis. So before going to the numericals, I would like to discuss some portion of dimension analysis and which would be very helpful for you to solve these questions. And the heart and soul of the dimension analysis is the principle of homogeneity, right? So it is the principle of homogeneity. Right? Right? So what does this principle say? This principle states that the dimension of the left hand side of an equation is equal to the dimension of the right hand side of an equation. Okay, so this is it. This is the principle of homogeneity, and based on this principle you can solve almost all the questions on dimension analysis. Okay, so let us see what is the application of the principle of homogeneity, right? So suppose I am taking a simple pendulum. This is the pendulum, and this is the mass of the pendulum. This is the length of the pendulum. Suppose it is displaced to this length by an angle theta. Okay. Right. Then let us try to solve the time period of this pendulum by dimension analysis. Okay. Though we know the formula, but we shall pretend that we do not know the formula. We try to find a formula by dimension analysis. Now, as you can see, by intuition we can say that the time period of this pendulum may depend on mass of the bob, right? Length of the string of the pendulum, acceleration due to gravity, right? And the displacement of the pendulum, that is the oscillation angle theta. So what I can do, I can remove this proportionality by a constant. So k, and I am writing m to the power a, l to the power b, and g to the power c, theta to the power d. Where a, b, c, d are some indices. That means I do not know with what factor the time period of the pendulum depends on this, that is on mass, length, acceleration due to gravity, and the angle of oscillation. I shall try to find them out, right? And you know that I can write time in terms of mlt, that is L0 T1, right? Theta and k are dimensionless, right? So I'm not taking them. I'm just taking the quantities that have some dimension. The mass I can write m, right? The length I can write L, right? And acceleration due to gravity is similar to acceleration whose unit is meter per second square, right? That means it is mass 0 L t to the power minus 2, right? So mass 0, no need of writing it because it is 1. So L t to the power minus 2 to the power c, right? Now solve it out. It is mass to the power a, L to the power b plus c, t to the power minus 2c. Right? So after comparing the dimensions of LHS and RHS, you can see that A is equal to 0, right? B is equal to minus C, right? And C is equal to minus half, right? So as a whole, if I put them all together, I hope you have noted down this. So as a whole, if I put them down together in this equation, right, what I shall get? I shall get that the time period t is equal to k, right, mass to the power 0 since a is 0, b is minus c and c is half. C is minus half, sorry, and b is equal to minus c, that means b is equal to half. That means L to the power half and g to the power minus half, right? If I write in this way, that k under root of L by G. As you can see, the time period is equivalent to the time period of simple pendulum, but there is a difference. There is somewhat a bit of difference between the time period that we have obtained now and the general time period of simple pendulum. We know the time period of simple pendulum reading Ts, we know it, that is, it is twice pi under root of L by G. See, this factor is same, right? But I am not getting the constant as twice pi, that is, I am not getting the value of k as twice pi. So this is the thing that I wanted to show, that using dimensional analysis you cannot predict the exact answer, but you can at least find the dependence, right? You can at least find the dependence. So wherever you see the question where only the units are enough and only dependence is enough to solve the questions, you should use the dimensional analysis. So though dimensional analysis is helpful in finding the dependence, but there is one drawback, that we cannot find the exact relation by using the dimensional analysis. Okay? So this is the application of dimensional analysis, right? Now we are going to solve some questions that was asked in the CSI NET exams, and I shall show you how dimensional analysis is very helpful to solve those questions in a less amount of time. So let us discuss our first question, which came in CSI NET December 2016. The question is, in the scattering of some elementary particles, the scattering cross-section sigma is found to depend on the total energy E and the fundamental constants H, that is the Planck's constant, and C, the speed of light. The dependence of sigma on these quantities is given by, right? So let me tell you, even if the last line, that is the dependence of sigma on these quantities, is given by, even if the dependence was not mentioned, then also you have to understand that this question can be solved by dimensional analysis, right? So these things you have to see. CSI demands these things from you, right? So let us solve this out. We know the cross section is proportional to area, right? Area, right? And area is equal to length. Area is equal to length square, right? So out of all these options, the one whose dimension is the length square, then it would be clear that that is the correct option, right? So I'm not wasting the time. You can check all other options, but let me solve the option of H by E, right? I'm solving this one. Let us see whether the option is matching or not. We know H. You have to remember that Hc has a value of 12400 electron volt angstrom, right? So I'm not writing the value. I only want the units, that is electron volt angstrom divided by energy. I know this could have been joule, but energy, as this electron volt, I am also writing the energy in terms of electron volt, right? Cancel this out. It is angstrom square. Angstrom is the unit of length. So that is why C option is the correct option, right? This is how you solve the questions. This was a very simple question, but you can begin with this question. So this is our next question, a CSI NET PYQ, right? Though this is the quantum mechanics PYQ, but this is based on dimensional analysis. That is why I have taken this PYQ. So the question is, the normalized wave function in the momentum space of the particle in one day is phi of p. That is, this is the wave function in the momentum space of a particle, right? So it is given by alpha divided by p square plus beta square, where alpha and beta are real constants. The uncertainty delta x in measuring the position is, that is, you have to measure the delta x and you have to express delta x in terms of this. So if you don't know dimensional analysis, then certainly this question cannot be solved in the exam, because it would take at least 20 to 25 minutes. That's because you have to find the mean square deviation delta x, then you have to find the mean square deviation delta p, equate it with h cut, then you have to find delta x, right? But if you know the dimensional analysis, then you can solve this question within seconds, believe me. So the normalized wave function phi p is given by alpha divided by p square plus beta square, right? So if you look carefully, you can see that we are adding the squares of these two terms. That means we are adding means they have the same dimension. Okay, that means we cannot add 1 liter of milk with 1 kg of sugar, right? Because the dimensions are not equal. If we can add, that means I have to add 1 liter of milk plus 1 milliliter of milk, like this, because the dimension should be equal, right? That means I'm writing the dimension of P is equal to the dimension of, sorry, there is a network lag, dimension of beta. Okay, so now if I use this formula, that I have to find delta x, right? So delta x, uncertainty in x, is h cut by delta p. Now p has the dimension of beta, that means this should be of the order of dimension of h cut by beta, right? Now look at the options, right? This cannot be the option because this h cut by beta square, this h cut by beta cube. Also there is a multiplication of alpha. We do not know what is alpha. Here also there is involvement of alpha and beta, though it is h cut by beta, but it involves beta under the root and also an alpha. Look at this, this is a constant, we don't bother about that. It is h cut by beta, so this is the correct option. You see, you can solve by dimensional analysis within seconds, right? If you solve this question by any other method, you can try it out, you can take it as an homework, you can try it out, and you would see that it would take minimum of 20 to 25 minutes to solve this question, and you cannot afford to solve a question in 25 minutes in the CSNET exam, because you have to solve many more questions, right? So that is the thing. So this is how the dimensional analysis is so powerful to solve many questions within seconds. There are many other questions which came in CSNET exam. I have given you a good idea how to approach this question. So I believe that the next few questions you can try on your own, and if you have any doubt, you can post it in the comment section below. So for today, I am stopping here, and I shall meet you in the next video. If you have any doubt regarding this video, you can post it in the comment section. I shall try to clear your doubt. So thank you everyone.